Before Chongqing East Railway Station could be built, a mountain had to be removed. Not moved around, not tunneled through. Removed. The site chosen for the largest high-speed rail hub in western China sat in Nan'an District in the Chaoyuannu area, in a city famous for terrain so steep and complicated that it has 11 layers of road built vertically on top of each other in some districts. Chongqing is not a flat city. It is a city built by people who decided that mountains were not an obstacle to be avoided, but a surface to be used. And when China decided to build a train station here that would serve the entire southwest of the country, it chose a site where the ground itself had to be fundamentally reorganized before a single foundation pile could be driven. Construction officially began on November the 22nd, 2018. The design blueprints were finalized in May 2022. From that point, the teams had 38 months to complete what is now one of the largest passenger stations on Earth. They did it. On June 27, 2025, Chongqing East Railway Station opened to passengers alongside the new Chongqing to Chunjiang section of the Chongqing-Xiamen high-speed railway. The station that required a mountain to be moved was open, fully operational, and already moving tens of thousands of passengers per day. To understand why this station had to exist at all, you have to understand what Chongqing is and what China's high-speed rail network is trying to do. Chongqing is not a city most people outside China can easily describe. It is one of the largest cities in the world by population and administrative area, a municipality in southwest China that functions as the gateway between the developed eastern seaboard and the interior provinces of Sichuan, Guizhou, Yunnan, and beyond. It sits at the junction of the Yangtze and Jialing rivers. It has been a trading hub for thousands of years. And in China's national rail strategy, the 8 vertical and 8 horizontal grid of high-speed corridors that the government has been building since the early 2000s, Chongqing is a node of exceptional importance. Multiple high-speed lines converge here. Routes running north to Beijing, east to Shanghai, south to Guangzhou, and west to Chengdu all pass through the city. The existing station infrastructure was not sufficient for the traffic those corridors generate, and it was not positioned to serve the new lines being built to connect the Southwest's interior cities to the national network. Chongqing East was designed to solve that problem. 15 platforms, 29 tracks including 6 through tracks for mainline services passing without stopping, a total construction area of 1.22 million square meters, 170 standard football fields, more than 4 times the floor area of Grand Central Terminal in New York. The station would connect Chengdu in 1 hour, Wuhan and Kunming in 3 hours, and Shanghai, Beijing, Guangzhou, and Hong Kong in 6 hours. When the additional lines currently under construction connect to the hub, Chongqing East will serve 7 high-speed lines, 2 conventional lines, 4 metro lines, and the full bus and taxi network of the surrounding district in a single integrated interchange. The 4-network integration model, long-distance rail, metro, bus, and suburban rail all in one structure, was a design requirement from the beginning, not an afterthought. But before any of that could be built, the mountain had to go. The Chaoyuannu area site in Nan'an District was chosen in part because it offered the space to build at this scale without demolishing an established urban neighborhood. What it offered instead was rock. The Chongqing geological formation is predominantly limestone and sandstone, the same material that produces the extraordinary karst landscapes of the surrounding region, the stone forests and river gorges that make this part of China visually dramatic and logistically challenging in equal measure. The site preparation required excavating and removing rock across a footprint large enough to accommodate a structure spanning the equivalent of a large urban neighborhood, and doing it to the depths required by foundations supporting a building of this mass and complexity. The excavated rock was not discarded. It was processed and reused as construction aggregate in the station's own concrete work. The same approach Japanese engineers used in the Choshinkansen alpine tunnels, turning the mountain that was in the way into the material that built the structure that replaced it. Chongqing's climate added a constraint that construction teams in most other cities never face. The city is known as one of China's 3 furnace cities, so called for summer temperatures that routinely exceed 40 degrees Celsius and are now regularly breaking records that were set within living memory. In 2022 and again in 2024, heat waves reached levels that forced conventional construction sites to suspend all daytime outdoor work. A project on the timeline of Chongqing East, with a fixed opening date tied to the completion of the Chongqing-Xiamen high-speed railway, could not afford weather-driven shutdowns that lasted days or weeks at a time. The answer was automation. China Railway Construction Engineering Group deployed a fleet of AI-guided construction robots across the Chongqing East site that became one of the most significant deployments of construction robotics on a single project in history. Autonomous welding robots operated through the hottest parts of summer days when human welders would have been pulled off the site. Rebar tying robots worked continuously through conditions that were unsafe for sustained human labor. Forehead screed robots finished the concrete floor surfaces of the station's enormous concourse areas with a precision and consistency that human crews working in 40-degree heat could not reliably sustain. Glass curtain wall installation robots handled the placement of the large facade panels that form the station's exterior skin. Tile-laying robots covered the floor areas of the finished interior spaces. Inspection drones flew continuous monitoring passes over the construction works, feeding real-time data back to engineers who could identify problems before they became delays. The result was construction productivity that defied the climate. Safety incidents dropped by 90% compared to conventional construction methods for a project of this size in these conditions. The timeline held. The robotics deployment at Chongqing East is now studied as a reference case for how construction in extreme climates can be maintained at pace without compromising worker safety and without extending deadlines that the national rail network depended on. The structural heart of the station is its roof. The roof covers 120,000 square meters, 12 full city blocks, and weighs 16,500 tons. That is a steel structure the weight of more than 2 Eiffel Towers, spanning the full length and width of a station the size of a large urban district. The engineering challenge of a roof at this scale is not simply the load-bearing design, though that is formidable. It is the thermal movement. Steel expands in heat and contracts in cold. And in Chongqing's climate, where summer temperatures can exceed 40 degrees and winter nights drop significantly, the seasonal temperature swing across a 120,000 square meter steel roof produces movement that must be accommodated without generating structural stress that accumulates into fatigue failure over decades of operation. The roof system uses a pipe truss steel structure carrying a combination of oval skylights and ETFE air pillow film panels. ETFE, ethylene tetrafluoroethylene, is a fluorine-based polymer that behaves like soft glass. It is lighter than glass, stronger than glass per unit weight, transparent to natural light, resistant to heat and chemical degradation, and self-cleaning in rain. It allows the roof to bring daylight deep into the station's interior while managing the thermal load that direct glazing at this scale and in this climate would produce. The ETFE panels are inflated, creating air pillow cushions between 2 layers of the film that provide thermal insulation equivalent to double glazing at a fraction of the weight. 9 spindle-shaped skylights pierce the roof, each one spanning approximately 2,400 square meters. Each skylight is built from 1,380 uniquely shaped glass panels. No 2 of them identical, because the spindle geometry produces a continuously varying surface curvature that standardized panels cannot cover. The shapes were cut and fabricated individually, numbered, and installed in a sequence designed to minimize the risk of error in a component system where mismatched geometry produces gaps or stress concentrations. The skylight forms draw their reference from the confluence of the Yangtze and Jiling rivers visible from the station site. The spindle shapes, echoing the form of water, where two currents meet. A piece of geographic identity embedded in the engineering of a glass and steel roof. Inside, the structure rests on tree-shaped columns. These are not decorative elements given a botanical name for marketing purposes. They are structural members designed in the branching geometry of trees, because that geometry distributes load efficiently across a wide horizontal span from a narrow vertical trunk. Each column branches outward near its top, supporting the roof truss above it across a wider area than a conventional column could serve at the same structural weight. The visual effect is a forest of steel within the station concourse, the canopy of the trees merging into the roof structure above. The design reference is explicit. The team described the architectural concept as mountains and rivers for thousands of miles, drawing on the imagery of Chinese landscape painting to embed the visual identity of Chongqing's terrain into the structure of the building that replaced part of that terrain. The 8-level structure contains the 4 network integration that makes this hub different from a conventional rail terminal. Trains from the National High-Speed Network arrive at the upper levels. Metro lines connect at intermediate levels. Bus termini, taxi ranks, and parking are distributed through the lower levels and the surrounding ground plane. The passenger who arrives by high-speed train from Shanghai and needs to reach a neighborhood in Chongqing by metro does not exit the building, cross a road, and enter a separate metro station. The transfer happens within the same integrated structure, with the escalator sequence and wayfinding system designed to minimize both walking distance and vertical level changes between modes. Peak hourly throughput capacity is 16,000 passengers. Daily capacity projections reach 320,000 passengers when all the connecting lines are fully operational. The energy footprint was designed with the same ambition as the structural engineering. The station is projected to save 6.18 million kilowatt-hours of electricity per year, compared to a conventionally designed station of equivalent scale, and to reduce carbon dioxide emissions by more than 8,000 tons annually. The ETFE roof system contributes to this by reducing the artificial lighting load during daylight hours across the full 120,000 square meter concourse area. Renewable energy systems integrated into the roof and facade contribute generation capacity. The building management system monitors energy consumption at the zone level in real time and adjusts building services dynamically to reduce waste. For a structure this large in a climate this demanding, those numbers represent genuine engineering achievement rather than aspirational targets that depend on perfect operational conditions. 38 months from finalized design to passenger service. A mountain removed and its rock recycled into the foundations of the structure that replaced it. A robotic construction workforce that maintained progress through summer conditions that shut down conventional sites. A 16,500-ton steel roof covering 12 city blocks, supported on tree-shaped columns, lit through 9 spindle-form skylights made from 1,380 unique glass panels. 4 transport networks integrated into a single 8-level structure designed to move 300 to 20,000 people per day between Chongqing and the rest of China. The city that built roads on top of roads because it had no flat ground to build on has now built the largest high-speed rail station in Western China on a site that was a mountain when the contracts were signed. The gap between what exists and what is needed has been the engine of every structure humans have ever built. Fill the gap. That is the whole job. That is all it has ever been. Like, share, and subscribe for more.